both as just one variable, and then we're going to talk about solving for a variable with other variables in it, which is the same process. Don't freak out by it. So when I solve for a linear equation, your job is just to get k by itself. That's it. We need to get k by itself. So I picked these two for particular reasons. They both come up with unique situations. These parentheses, if you have a parenthesis and a negative sign out front, that negative sign is really a -1 in hiding, and you need to distribute that negative. It is a common mistake I see throughout math careers that we don't realize that this negative gets distributed to both. So that means we're going to have 39 minus 5k equals 1 plus 8 plus k, because I'm subtracting that whole thing, and I distribute that negative sign, and I have a plus action. So the first thing is always get rid of your parentheses. Get rid of those. And then the next thing is simplify each side. I don't know how good you are at simplifying these, so I'm going to go through every single step by step. So the left-hand side, I have no like term, so I'm at 39 minus 5k. The other side, I do have a 1 plus 8, so that's going to be 9 plus k. Now, I know I need to get k's on one side and I need to get the numbers on the other side. Now, for me personally, I like to create positive k's, so I'm not dividing by a -1. So typically speaking, I'll see this -5, I'm like, whoa, if I add 5k to both sides, I will have a positive k on this side. So I would choose that. You can subtract k, and you just end up having to divide by a negative, which is fine. I prefer just adding 5k to create that positive k on that side. So I'll add 5k to both sides, which will give me 39 equals 9 plus 6k. Now I should subtract that 9 from both sides. That will give me 30 equals 6k. That 6 is attached to that k by multiplication, so I'm going to divide both sides by 6, which is just going to create k equals 5. Now, if I wasn't teaching this in class, you might want to plug it in and make sure it's the right answer. If you have time on a test, you know, people that, like, if you get done like 10 minutes early, maybe plug those in and make sure they work. I will talk about some today that you need to check, because they will always trigger ones that are extraneous solutions. But we'll get to that in a second. All right, next one. Don't forget to distribute. Now, the reason why I picked this one has two reasons. First reason is we are doing fractions. As a reminder, when you multiply fractions, you are multiplying the numerators and you're multiplying the denominators. You do not have to have a common denominator to multiply fractions. You need them to add or subtract, but multiplying is just straight across. So let's go ahead and write the left-hand side. The left-hand side is 3x plus 11 minus x equals, so I go straight across, so I have 3 times 4, which is 12. I have 2 times 3, which is 6. And we have times x plus, well, that'd be 3 times 12, which is going to be 36 over 2. Because don't look at that 12 as just being a 12. Think of it as being a 12 over 1. If that's a 12 over 1, then I have 3 times 12 and 2 times 1 giving me that 2. And then we have that plus 7. Let's start reducing slowly. So on this left-hand side, I have a 3x and a negative x. So I should have a 2x plus 11 equals 12 divided by 6, which is 2x, plus 36 divided by 2 is going to be 18, plus 7. I now have 2x plus 11 equals 2x plus 25. That right there is a unique situation. And maybe you don't realize it yet, but that's a unique situation. 2x plus 11 can never equal 2x plus 25. And if you don't realize it there, my next step would be to get my x's all on one side, which would mean I would subtract both sides by 2x. But if I subtract both sides by 2x, my variables cancel out, and I'm left with 11 equals 25. Does 11 equal 25 in math? No, if it did, it'd break math. That does not equal. So we could have noticed it here, but we definitely notice here that these are false statements. 2x plus 11 cannot equal 2x plus 25 because 2x is the same on both sides. It doesn't matter when you recognize it. You just need to recognize that that is a false statement. A false statement means it's inconsistent. So you have two ways to put inconsistent. We can just write inconsistent. Inconsistent. Does that have an E or an A at the end?
It's an E.
It's an E. Thank you. Thank you, spellers in the class. I just manipulated that to be an E. All right, inconsistent. But what I usually do is I just put a circle through a line through it. That's just as quicker. Both mean the same thing. Both means that there's no answer. So a circle with a line through it means it's inconsistent. Your choice. I would just do the circle through a line through it, or just tell me no. Yeah. All right, so both of these would be acceptable answers. Inconsistent, or just a circle with a line through it. What would happen if this was a true statement? What if this came up to 11 equals 11? It'd be all real numbers, which we'd put either all solutions, all real numbers, or you can also, just for the sake of it, you can put the boldface R, which looks like that. That stands for all real numbers as well. So there's multiple ways to say all solutions. All solutions, all real numbers, or you can just put the all real cap R action. Okay, questions on solving? Okay, then let's push on. Let's push on to solving literal equations. Solving literal equations means that you're solving for a particular variable when there's multiple variables. This means your answer will not be a number. It's going to be still an equation. It will still be an equation. You have to look out for what I need to solve for. So I need to solve for J. I need to solve for J. So let's look where J is. J is, bless you, trapped in a fraction. Here is the ultimate rule for dealing with fractions when solving equations. It's easier just to get rid of them. We're going to get to that when we do rationals as well. The easy way to get rid of a fraction is to multiply by the denominator. So I don't care that the J is trapped in here. If I want to get rid of this fraction, I need to multiply everything by this denominator, which is 3J. So I need to multiply both sides by 3J. I'm going to do it this way. I'm just going to tell myself I'm multiplying everything by 3J. This 3J will cancel out with this 3J, leaving me with just 8H on this side. On the other side, I'll have 3J times 6K, which will be 3 times 6, which is 18. K times J. All right, I still need to get J isolated. That's what solve for J means. I need J all by itself, so I need to get rid of this 18K. Well, I need to divide by 18K is correct. So I'm going to divide both sides by 18K. So when I divide by 18K, oh, yeah, I'm sorry. I forgot to put it right there. When I divide by 18K, we're going to have 8H over 18K, but I know, what do we got? We got 4 that goes into it, so I'm going to actually have 4H over 9K equals J. All right, the next thing I want to talk about is, so I want to talk about this, and I'm going to juxtapose it next to number 2. Number 2 has more than just the parenthesis on this side. It also has a +7. So that's why I chose to distribute this. If we look at this one, I need to get B sub 1 alone. Well, we could distribute this 1/2 H to both of those. But I'd be more inclined, since there's nothing on this side, to move this fraction to the other side. So once again, to get rid of a fraction, multiply by its denominator. So if I want to get rid of 1/2, well, I'm just going to multiply both sides by 2. Now be careful when we multiply by 2. So I'm going to have 2, maybe I'll change my color here. I'm going to do 2 times this side, and I'm going to do 2 times this side. This 2 will only affect this 1/2. I'm not going to distribute it in here. I'm not going to multiply everything by 2 because this 1/2 is already on the outside, so this 2 already affects everything. So we're going to have 2 times 1/2, which will just be 1. On the left-hand side, I'm going to have 2a. So I'm going to have 2a equals 1h times b sub 1 plus b sub 2. Once again, I don't want to distribute that 8 because it's already factored out. So what I can do here is I can divide both sides by h. That will get my h's to cancel out because everything's attached by multiplication. And on my left-hand side, I will have 2a over h equals b sub 1 plus b sub 2. Now realize I need to get b sub 1 by itself, so that means I need to move that b sub 2 to the other side. Well, that's just a number. I can subtract a number. So I'm going to subtract b sub 2 from both sides. So I'll have a minus b sub 2 minus b sub 2. And our end answer is going to be 2a over h equals, not equals, but minus a b sub 2 equals a base 1. And now we're done. So maybe I'm writing a program that deals with areas of a trapezoid, but I always know the height and the area, and I need to find a specific base. It's going to be a lot easier using this equation to solve it all than making it go through all of this work every single time. Now I can just find the area, height, and base 2, and I will get my base 1 out. So that is solving for literal equations. My next one is a special case. And there's really only one key way to solve this one. So the second one, I'm going to notice I am solving for m. How many m's are in there? There are 2 m's. There are 2 m's. I need to turn those 2 m's into 1 m. The way you're going to do that is you are going to factor. To turn something from 2 into 1, you need to factor. This is, and probably there's another way to do it, but it's a lot more difficult. This is a factor problem because you have 2 m's. Because you have 2 m's, you have to factor it. I know about half of us won't on the quiz because you won't pay attention to this, you won't write it down, you won't go, oh, I should study the special cases. But this is a special case because I have 2 of these m's. I need to get all of the m's on one side, and I need to get everything that doesn't have an m on it to the other side. So I'm going to move this 2m to the other side, giving me mn minus 2m minus p equals 0. Now, in order to factor, there must be an m in all 3 terms. There isn't. That's why we have to get stuff that doesn't have an m in it to the other side. You can't factor it out unless it's in everything. So I'm going to move the p to the other side, giving me mn minus 2m equals a positive p. And now I'm going to notice there's an m in both of these terms, which means I can factor out an m out of both of those, resulting in m times the quantity n minus 2 equals p. I have now turned 2 m's into 1 m. This 1 m is attached to stuff I don't want by multiplication. As long as it's all in one parenthesis, I can divide by the stuff I don't want. So I'm going to divide by n minus 2 on both sides. That's going to end up with m equals p divided by n minus 2. Realistically, this is like the hardest problem that's in any one of our linear equation solution section. just because people forget they have to factor. If you know how to factor, these problems are really, really easy. If it's not, I will see like a crazy amount of work on here, and you still won't get much credit because you'll have 2 m's. Unless you know how to factor, you're not going to be able to get rid of one of those m's. So make sure you understand if you have more than one of a variable, you need to factor. All right, that's solving literal equations. The last thing we need to talk about are solving absolute value problems. Absolute value problems create more difficulty because we're actually solving 2 equations. And the reason why we have to solve 2 equations is, if I come over here really quick, let me give you an example. Let's say x equals 2. Absolute value of x equals 2. What does absolute value do?
Positive.
It makes everything positive. So would you agree that if I plug 2 in here, would that give me the answer I want? Is the absolute value of 2, 2? Yes. But the thing is, negative 2 will also get me that same answer. The absolute value of negative 2 would also be 2. Yes?
But the negative's on the outside, so it would be negative 2.
It would be a negative 2, yes.
Absolute value 2 would be negative 2.
Yes. Yep. So what happens is, just like you said, this breaks apart into 2 possibilities. Either x equals a positive 2 or x equals a negative 2, where we just adjust the other side. We adjust the other side. So the absolute value disappears as long as I account for both the positive and the negative of 1. Now, real quick, I want to talk about one more situation. You said the absolute value of x, the absolute value makes something positive, right? Can the absolute value of x ever be a negative 2? No. Can the absolute value of x ever be negative 2?
Well, I mean, if you have the negative outside the absolute value.
But do I have one? No. So this is a false statement. This is just false. It has no solutions. So be on the lookout for an absolute value equaling a negative number. Because what I'm looking for is no solutions. That's false. An absolute value can never equal a negative. So keep that in mind, because we're going to get the problems that are going to have what's called extraneous solutions, where we solve the whole thing, and the answer doesn't actually work, because when I plug it back in, it creates that situation. But that won't be this problem. This is a very basic problem. This says, hey, absolute value of negative 2 minus 10w equals 98. Well, the absolute value of 98 equals 98, but the absolute value of negative 98 also equals 98. So I have to account for 2 possibilities. Either what's in here equals a positive 98, or what's in here equals a negative 98. So that absolute value breaks us apart into 2 possible situations. Either negative 2 minus 10w equals 98. If that's true, absolute value of 98 equals 98. Or we have to create another situation. So to get rid of the absolute value bars, I have to break it apart into 2 possibilities. Or negative 2 minus 10w equals a negative 98. Because if whatever's in here equals a negative 98, absolute value of negative 98 equals a positive 98. So we need to get rid of those absolute value bars, but to do that, we have to set it up equal to the positive version of the right-hand side and the negative version of the right-hand side. Then we just have to solve these 2. So on the left-hand one, I need to add 2 to both sides. Well, this one's going to come out nice because I have negative 10w equals a hundo. Divide both sides by a negative 10, and we'll have w equals a negative 10. So if I plug negative 10 in here, I'll have, negative minus 2 minus 10w. So minus 10w would be plus 100, negative 2 plus 100. Oh, that equals a positive 98. Absolute value of 98 equals 98. That's good. All right, for the other one, we're going to have to add 2 to both sides. That's not as nice. We'll have negative 10w equals negative 96. We're going to have w equals a negative divided negative equals a positive 96 divided by 10. Maybe I'll put both negatives on there because I do have to simplify this. I should note at least 2 goes into both of those. So that would be 48 over 5.
You go either way, or you can do both.
You have to do both. I'll write that in a second. So you could, there's 2 ways to give me the answers. First of all, if I had my calculator, I would just plug this in and check it real quick. I would just, because in your calculator, you can just plug it in. You can just go -2 minus 10 times that. It's real easy. If you know how to use your calculator, it takes like a second to check your answer. And if it's wrong, doesn't come out, you can put either doesn't work or I have to go back and check something. These are really, really easy to check. Just plug in your calculator and check it. Now, there's 2 ways to give me this answer. First way, just box in both answers. Just say they both work. Or you're going to see a lot on the answer key where I do this, W equals, and if I'm giving 2 answers, I use braces, and I put them in order from least to greatest value. Now I have to use these braces because if I use parentheses, parentheses would mean that it is a bunch of answers. It'd be so if I use parentheses here, it'd be from -10 to 48 over 5 would be our answers, and we'll talk about that when we get to inequalities. So make sure if you're giving me the answer in this way, you use braces. Braces let you know that each one's individual. It is not a bunch of answers that are between it. Yeah?
How come you made the 98 negative?
I took the 98 from here.
Yeah. But how come you turn it negative?
So it's negative here, right?
Yeah.
Are you okay with it still being negative here?
I'm just confused why it's negative, because up there it's positive. 98.
Oh, that comes from this. That what goes inside an absolute value can either be the positive version of our answer or the negative version of what we want.
Okay.
So right now, if you don't believe me, that's why I said plug it in your calculator and check it. If you plug in 48 over 5 into this equation, you'll get out -98. What's the absolute value of -98?
98.
98. So I have to account for this equaling a -98 and a positive 98. Because when I plug it in, that's why I strongly encourage you check your answers. Because the more times you check it, the more you understand what you're doing. If you don't take that extra step, then you're just doing it out of memorization. But if you actually check all of your answers, you start understanding why we're setting them up, that they both work. So I highly suggest, at the very least, you take your calculator and just plug it in and make sure it works. Because the last thing you want to do is just memorize stuff. It's much easier if you know why you're doing stuff than just memorizing it. Okay. My next one. Now, I didn't really talk about this because this was already done for you. But your first step in solving absolute values is actually to isolate your absolute value. This one was already isolated, so I didn't talk about it. But over here, it is not isolated, so I can't break it apart into 2. It's kind of like when I have a square root. I need to isolate that square root before I square both sides. So before I do anything with this absolute value bar, or absolute value, I need to isolate it. We need to isolate it, which means I need to get rid of that 1 and I need to get rid of that -10. The 1's easy because that's just subtracting 1 on both sides. So my new equation is going to be -10, absolute value of 9r, plus 3 equals -1 on both sides, and I'm going to have a -30. And if it helps you, if you don't understand what's happening, make sure you're writing, I don't always write the little in-between steps, but I'm just subtracting, bless you, 1 from both sides. Then I need to get away from this being some magical thing. This is -10 times a number. It is attached to this by multiplication, just like if it was parentheses. So if I need to move that -10 to the other side, I just divide by -10. So I'm going to divide both sides by -10. A negative by a negative equals a positive. So I have absolute value, 9r plus 3, equals 3. You're a 0. Calling me a 0. All right, absolute value bar, it means there's 2 possibilities. This, once again, is just like it could equal a positive 3 or it could equal a -3. Because if I put a -3 in here, absolute value -3 equals 3. A positive 3 equals 3. So it creates 2 different equations. Our first one is 9r plus 3 equals 3. Just leave it as is. Just get rid of the absolute value bar. The other option is it could equal a negative 3. Or what's in here could equal a negative 3. Well, does it make a little more sense why I have that negative this time?
Yeah.
Okay. All right, first one. Let's go ahead and solve it. I will subtract 3 on both sides. Minus 3, minus 3. We have 9r equals 0. We're going to divide both sides by 9. And we're going to have r equals, now here's the weird thing about 0. Sometimes divisions with 0 are undefined. Sometimes they equal 0. What is 0 divided by 9? Is that undefined or is that 0? 0 is on top is fine. So this would actually equal 0. Let me tell you how I remember this. If you go to the beach, is it okay if you have no shirt on as long as you have some trunks on?
No.
Most beaches. Yes.
That's the low end.
Is it okay if you go to a regular beach with a shirt on and nothing on bottom? No. No, we're not in Barcelona. We are on a regular beach. I'm just trying to help you guys remember this, so don't go to the weird cases. It is okay if you have nothing on top and something on bottom. It is not okay if you have something on top and nothing on bottom. So you can't divide by 0, but you can have 0 on top and divide and equals 0. So 0 divided by 9 equals 0. That's one of my possible answers. If you would plug 0 in right here, 9 times 0 plus 3 is 3. Absolute value of 3 is 3. Now we also have to solve for what happens if it's negative 3. So we're going to have 9r. I'm going to subtract 3 on both sides. Equals negative 6. So we're going to have r equals a negative 6 divided by 9, which is going to equal negative 2 over 3. If you do negative 2 over 3, negative 2 over 3 times 9, that's going to give you a negative 6. Negative 6 plus 3 is a negative 3. Absolute value of negative 3 gives me back out that positive 3. Both of these are legit answers. Once again, you can either box both of these in, make sure you have both of them circled or boxed in, then I know both are answers. Or you can just simplify this by putting r equals negative 2 over 3, and it also equals 0, making sure you use braces if you're using this method. All right, like I said, when I solved for those linear equations, I said there was a special case. When I did those literal expressions, I said if there's ever 2 variables, you have to factor something out. That's not the same thing here, but I do want to point out that these are special cases as well. This is a special case that will have extraneous solutions a lot of times. You're going to know it has extraneous solutions because look at the difference between these two. One has a variable outside the absolute value. This one does not. Now, what I want to point out here is an absolute value can never equal a negative number. When you solve this, your equation isn't going to know that. You have to know that. You have to know if I plug in this answer and this side comes out to a negative, I need to know that that's an extraneous solution. So be aware, a problem like this has extraneous solutions. If I put this on the test, you better believe I'm going to pick one that has extraneous solutions in it, because that'll be one point of the problem that you realize that I should plug it in and check it. So once again, I don't care if you note this in your notes, you probably should, but this is a special case. This has potential extraneous solutions. So first of all, we do it the exact same way. First of all, we isolate our absolute values. Oh, they're already isolated. Cool. All right. So that means I need to set up 2 equations. I need to set up one where we have 5a plus 8 equals what's on the other side. You leave it alone. Absolute value bars are always dissolve them and have one that just is the exact same without the absolute value bars. Now, my or statement is going to be a little bit different. Be careful here because we're going to dissolve our absolute value bars. So I'm going to have 5a plus 8. Those are gone, but I need to take the opposite of the other side. I am not taking the opposite of 3a. I am taking the opposite of the entire thing. So don't just put a negative sign out front. You have to switch every sign that's on the other one. You are doing negative everything, so I'm going to use a parenthesis there, making sure that that negative gets distributed. So my two equations are going to look like this. I will have one that is 5a plus 8 equals 3a minus 10, and I'll have one that flips both of those signs. 5a plus 8 equals a negative 3a plus 10. The complete opposite of that other side. Then we just go ahead and solve our way through this one. I'm going to go ahead and I'm going to subtract 3a from both sides. I don't care how you solve these. You should have a method for solving, I hope at this stage in your math career. So I have 2a plus 8 equals a negative 10. I am going to subtract 8 on both sides. Ooh, let's go back to my purple color. Subtract 8 on both sides. I'm going to have 2a equals a negative 18. Divide both sides by 2, and I should end up with a equals a negative 9. Let's go to the other side. I'm going to add 3a to both sides. That's going to give me 8a plus 8 equals 10. I am going to subtract 8 from both sides. That's going to give me 8a equals 2. 2 divided by 8 is 1 over 4. I guess I could go through all those steps. A equals 2 over 8, which equals 1 over 4. If you did all of those steps on the test, you lost a point. You lost a full point. I didn't do anything wrong. I just didn't do the extra step, realizing that this is a special kind of problem. Now, I want to remind you that the right-hand side can never be negative. An absolute value can never equal a negative number. So you need to plug these in here and make sure they don't come out to a negative number. So for example, so let's take that negative 9 and go 3 times that negative 9 minus 10. Does that equal a positive or a negative number? Negative. It equals a negative number. I don't even care what negative number that is. You could plug in your calculator. Do you need someone? Yeah. I don't care what negative number it is. If it's a negative number, it does not work. This is an extraneous solution. What was that? Now we have to try the other one. So you have to try it. Don't assume one of them will work. Don't assume one of them will work and the other one won't. It could be a case where they both work, one works, or none of them work. So let's go ahead and plug in 1/4. And you can plug this in your calculator. We have 3 times 1/4 minus 10. But my big thing, is that turn out to be a positive or a negative? It's going to be a negative. There is no way that 3 times 1/4 is bigger than 10. So we end up having a negative. Can someone tell me what decimal that would be? Did anyone plug it in? 9.25. 9.25. So this is in fact a negative 9.25. I guess I could have did that because it's just 3/4. So this one also doesn't work. So this is no solutions. There is no solutions on there. So be careful. If one side, this side will always work. The absolute value will always work. No. I'm sorry. We're on this problem, though, right? Yeah. Okay. So we should.
We decided that side is
Mm-hmm.
that side. So you still want us to go and work that.
This one over here? Yes, you should put both of them in. You have to check both of them because, like I said, you have 3 cases. Either they both don't work, they both work, or one works and the other one doesn't work. I'm going to tell you the one on the homework, one of them works and one of them doesn't work. So make sure you're checking both of them. You don't just check one and go, oh, they both don't work. You have to check both of them. In fact, that reminds me, can we, I have my notes somewhere. Can we go to number 20? Let's go to number 20. I don't have it up here. But we're going to change number 20. Number 20, we are going to make 1/2 absolute value 9a plus 3 equals 3a minus 6. So let's change number 20 to that one.
Oh, because it's the same as 18.
Yeah, and I also give you 2 chances to understand those special, because those last 2 should be special case ones. Better than just giving you 1 practice, we'll get 2 practices on there. So we are making number 20 1/2 absolute value, 9a plus 3 equals 3a minus 6. Yeah, yeah, go ahead. Can you make sure your homework's out if you have it, that 1.5 that was due on the quiz day?
Yes.